Hello, and welcome to the second normal form. Okay, now we have our database in first normal form as it pertains to normalization. Now what we want to do is look at second normal form and what that's all about and continue on with our process of normalizing our database. With that, for this particular video, we're kind of going to follow the exact same steps. So we're going to talk about what second normal form is. We're going to recognize when a table is not in second normal form. We're going to talk about what it accomplishes, how we apply the rule, and then once again, we'll kind of do it together. All right? So what is the second normal form? The second normal form is really easy. It basically says eliminate repeating redundant data from our table. So in this case, what we're going to do is we want to make sure that data that's repeating, not columns now, data that's repeating, that's redundant, that's in our database over and over again, we eliminate from our table and we create a new table where that repeating data is only in the database one time and then represented by a foreign key. Does that make sense? Kind of bear with me. You'll see what happens here. All right, how do we recognize it? Well, we analyze the data within our table. All right, we recognize data in in the same columns that is redundant. So let's go out of here for 1 second and get back into this. Okay, I have not normalized this spreadsheet, of course, but I want you to look at some of the data. And so if I sit back and look at a few things, what is redundant in here that's in the same column? Look at the states: Ohio, Ohio, Ohio. Cities, that's the same. If we come over here, we have some courses that are the same data. If we come over instructor-wise, there's instructors that are the same. You notice that? That's called repeating data, repeating redundant data. We do not want that in our databases, okay? Here is the situation where even after everything you've done up to this point in regards to database design and creating your physical databases, that we can really truly analyze your tables a little bit more to ensure we don't have repeated redundant data. You've probably already seen this. You may have already seen this in your databases and say, well, those probably are separate entities anyway. And if that's the case, good for you. You're actually moving in the right track there. But by applying this rule, we can ensure it. Okay? That's what we're going to do. Now the question comes down to is, do we always eliminate everything that's redundant? Well, let's go back to our PowerPoint presentation. And I believe you need to ask some of these following questions. Let me tell you what, let me get this bigger here. Get back to where we were. There we go. So when you look at a column, you see repeated redundant data, okay? You should ask the following questions. How often does the redundant data occur? Is it every other record or is it 1 out of 1,000 records, all right? Based on this, is it worth breaking out? So what do I mean by that? Well, let's think about address for a second. I have that student database with addresses in there. And as you well know, it's possible that in Cincinnati State, two people could live at the exact same address. Could be roommates, could be brother, sister, could be whatever. All right. But how often does that occur? Does that occur every other record, every 50 records, every 100 records, or one every 1,000 or 10,000 records? If it's only every once in a while, it may not need to be broken out. It might not be worth being broken out. Okay. And that's what we're saying here. Is the data important or critical? Will redundant data likely be cause problems? And if we go back to our anomalies again, where we have modification, remember our update anomaly where we sat back and said, well, if they changed their address, okay, could it affect multiple other records throughout the database? If the answer is yes, you need to change it, okay? If the answer is no, it's not that big a deal and it really shouldn't cause too many other issues and it's not that critical, maybe having that redundant data in your database is not that big a deal. Finally, are the fields involved used for searching or sorting? The more the fields are used, the more likely it is that they need to be accurate. So, will I be searching on address? Possibly not, but could I be researching on state, on instructor, on course ID, or the course name? The answer is probably yes. So that means it's critical and it must be accurate. We don't want misrepresentations in the database, meaning we don't want somebody typing my name, for instance, Nields, Neilds, which is done a lot of times, trust me. All right? Because if they spell my name incorrectly, in one instance and another instance correctly, when you search for me, based upon how you search, if you search for it with the correct spelling, anytime I have the incorrect spelling out there, it will be wrong. So I really want the instructor to be in the database one time and then represented accordingly through a foreign key. All right, does that make sense? This one's a little bit tougher than the first one, I believe, but not that big a deal. We just need to look and eliminate redundant data. It's not that hard. Interesting enough, you could look at these questions and then realize, I don't know, I should just go ahead and normalize everything. You wouldn't be wrong. There's nothing wrong with it. But sometimes these tables become such maintenance issues that, by breaking all of them out, just because of the potential of redundant data, or maybe a couple records are redundant, could cause an issue. Okay? Anyway, let's continue on here. So what's it accomplish? Well, data integrity. We already kind of mentioned that. We want to be accurate. We don't want my name in there twice spelled incorrectly. I can't search on that. Elimination of modification anomalies. We just talked about that. If it's a case where we sit back and say, I need to modify this field, and if I need to modify it, but it's redundant all the way through the database, I would need to modify it in all those records, which could cause problems. But modifying it once and then having it being, the way I would say, represented in multiple places, that makes sense. Okay, this is truly, as a software developer, an IT professional, our goals are to do things one time, make it efficient, and eliminate the possibilities of error. Okay, so when it comes to relational databases, these normalization rules that you're learning, doing things one time in programming, object-oriented, building functions and procedures, the goal there is not so much that we need to have all of this. The goal is that we want to make it be very efficient in regards to how everything works. And there's been so much work done over the last 40, 50 years to allowing this to be done better and more efficient. And it's really has stuck. And it's good that you're at this point in time in learning this, because these are things that have been tried and tested and have worked. Okay? How do we apply this rule? Well, we're going to create a new table with a name representing the redundant data. In this case, T instructors, T cities. We're going to create a unique primary key for the new table. We're going to be very consistent there, instructor ID, city ID. This new table now will become the parent, okay? Because we're basically saying, in this case, say for state, for instance, that we're going to have Ohio represented one time, but for every state, there could be many students. Does that make sense? So for every state, there could be many students. So the state table, in this case, will become the parent table. And therefore, the table that it originated from will be the child table, a little bit different from first normal form. Okay? Therefore, the child table will hold the foreign key, representing the primary key of the new parent table we just created based upon the second normal form. We're going to move all the attributes representing the redundant data to the new table and delete all moved data from the child, the originating table. There you go. Not too hard. Let's go ahead and look at an example of this, okay? And kind of get into it, all right? So in this case here, I mean, the only way you can really tell if data is redundant or not is to actually look at the data. That's what makes second normal form a little bit more difficult to recognize. As you get better and better at this, you'll start recognizing it based upon your design. The potential for redundant data is really what you're starting to look for. So when you're designing a database, you start looking for potential of redundant data. However, learning it for the first time, you kind of need to look at the data and see where it actually is redundant, okay? So as you're getting used to it, analyze the data a little bit, As you get better at it, you'll start recognizing the opportunity for potential redundant data. All right. So once again, you see instructors being redundant from 111 to 100 for course 2. Doug Bowling is teaching both of those. The courses are redundant, aren't they? And again, states are redundant as we kind of go through. All right. Even in this case here, yeah, books are redundant. You see that? That I can use Introduction to VB in 101 and 102. So there's a lot of opportunities here when we actually get into this. All right. So what do? Well, the first thing to do is look at state. Let's keep it simple. All right. I'm not going to do it for every possible scenario here, but as we mentioned before, city could actually come out, state could come out. Okay. The instructor could come out into its own, and so could the book. So in that case here, we would literally create 4 tables. All right. Let me show you how to do a couple, and then that should be help you get well on your way. So with that said, we'll create an entity table here. And we'll do that for state. Okay, so we'll just call it state. We'll have an attribute called int state. All right. I'm going to go ahead and delete these things. I like doing it this way. We will then bring down, let me kind of go up here a little bit, and we'll bring down state right here. And I'm just going to call it state, okay, like this. All right. And because I could use this state table in multiple places. I wonder if I want to, is to not only have information on the student, I could also have information on the instructor on where they actually live. So I can actually use this state table uh, in multiple different entities and multiple tables based upon that, if that makes sense. All right. So what else do I do? So in this case here, what I'm going to do is I did everything here. I created a table. Then I need to create the foreign key from the originating table. All right. This is going to be the parent table. This will be the child table. So I'll go ahead and let's see, I'll add up right back in here. And this will become the state ID. All right. I did this wrong right here, didn't I? I'm taking this right to physical databases, sorry. So this should be state ID, representing the same thing, okay? And once again, let's go back up here, do a left click, and say set as foreign key. There you go. So now that's the state ID representing the state. And the relationship to this will be, make this straight. There you go. That for every, this is actually already done for us. Yeah, yes. So, well, not quite. But for every student, they must come from at least one state, right? And in this case, and then for every state, there needs to should be, well, that's fine, 0 or many students, because we could have states in our state table, and no students are actually from those. So there you go. We have just now did second normal form when it comes to state. You see the difference there? Now state is represented in our table. If you actually looked at that state table and built it out, you would put in there 50 records, one for every state. Versus if we had a million records in our database, the word Ohio being written out 10,000 times, or maybe, who knows, 100,000 times, Kentucky being written out 100,000 times, and so on. You get the idea? Now they're written out one time, and then they're represented by a foreign key. So not only are we dealing with anomalies, and we're dealing with our modification anomalies and so on in that regard, we are also saving space because now we're representing Ohio once we populate this table, maybe with a primary key of 1. So instead of storing 4 bytes for Ohio, OHIO, okay, we would be just storing 1 byte for the number 1. For Kentucky, I don't know how many letters that is. We'll assume 10. With that said, we're storing 1 byte versus the 10 bytes. And if we had a million records, that adds up. So there's actually some benefit to that also. Okay, makes sense. Once again, so we just eliminated that redundancy. Cities, once again, that could come out if you wanted to. All right. Instructors, that makes a lot of sense to me that we would be pulling out the instructors in this case, and also courses. So let's go ahead and do courses and instructors really quick here and watch how this table changes, okay? And so what I'm going to do is I'll go ahead and add a new entity name right there, kind of increase this page. And we're going to go ahead and we're going to make courses here, okay? So in doing this, following my rules, all right, we create the courses table, that's what it's representing. Then we would go ahead and we would have a course ID, of course, right? Sorry about that. And with that said, we're going to go ahead and delete these attributes. We will bring over the data that we're feeling is redundant. Okay. IT 111, you saw that in our table here. Multiple students have taken it, so it's being represented over and over again. All right. So we want to bring that over. So we'll just sit back and we'll call this the course, I don't know, number or description. We'll just do something like this for right now. Okay. Got it? We'll put our primary key, I'm sorry, our foreign key back here. This will now be course ID. So we're going to now represent that based on the primary key there. So this will be a foreign key. There you go. Course description. And then our relationship here is, let's see, make this straight. Is this. For every course, there can be many students. Okay? Now, analyze this for a second, people. All right? Look at what we just did. We just created a student courses to courses. And if you actually look at this based upon your design that you've done before, and based upon what we've done here before, remember what we said at the first time when we were designing this database? That for every student, there could be many courses. And for every course, there can have many students. And because we recognize that relationship in our design, we knew we needed to have three tables, one named based upon the two parent tables. But look what happened. So following the rules of normalization, we got there the same. We got there anyway. Do you see what I'm saying there? Okay. So now we have almost a many-to-many table here that sits back and says, for every student, they can have multiple courses, and for every course, there could be multiple students. Kind of cool. Makes sense? As I told you before, what we're doing here is not brand new. You've done it. We just did it in a different way. We came about it from a different point of view, all right, which I think is easier to learn. But in the end, normalization gets us there too. Our goal is, as I repeat this one more time, is to teach you to make sure you analyze the tables that get you there. All right, like state coming out, city coming out, and then finally instructor and also book. Okay, so I'm going to, if I do the book one here, this would be the books table. And then now our books will not be repeating. Why do I keep adding that D? And we'll just call this book description, okay? And I'll delete, oops, let me do a undo there. There we go, get rid of that attribute. This right here, we were going to just rename the book ID. There we go. And we'll make this, come on, there you go. And we'll make this into the foreign key, maybe. There we go. And we would form that relationship, kind of going through there one more time, and it'd be one to many. All right. And so I'm not going to bore you with that. I'll fix that up, and then you can have it as part of your resources for this week. Anyway, that is the second normal form, looking at every table and recognizing potential duplicate data or duplicate data, and then answering those questions that I gave you. Is it worth breaking out? Like I said, if we sit back and kind of look at some of the other potential duplicate data, last name. There's a lot of Smiths in the world. Should we break that out? I don't know. That might be really tough to maintain, really tough to bring back together again. Is it really worth doing? High schools. Yeah, we could have some people in here with the same high school. Is it critical? Is it worth doing? Is it happen very often? And so maybe we wouldn't do that. All right. So that's what you kind of look for. But you're looking for the things to kind of do this to that are redundant, that are critical, that could affect different anomalies that we already talked about, and also that will aid in our overall searching to ensure that all our data that we're actually going to be utilizing for searching is accurate. Meaning, I want to know everybody who took IT 101, so it needs to be represented accurately at all times. I want to know everybody who has taken Bob Niels, so Bob Niels needs to be accurate at all times. So I would definitely bring out that course instructor table. All right. Whew, there you go. That's called second normal form. We're getting there.